Welcome to this talk. Today we're going to look at the question on whether Kubernetes is the new OpenStack. My name is Julian Fischer. I'm CEO of Any9s, and what we are doing is operating and planning platforms on behalf of customers, including Cloud Foundry, Kubernetes, and we also automate the lifecycle of many data services to work alongside with those platforms. So first of all, a few words about contents of this talk. They are highly opinionated. If you have different viewpoints, feel free to add them in the comment section if you're looking a video version of this talk, or contact us via social media. Or if you happen to be in the audience of the talk, just ask your questions right away. So the first aspect of this talk is what was the original mission of OpenStack? And here, maybe it's not exactly the mission statement that you can find on the openstack.org website, but maybe it was the expectation of crowds and people who adapted OpenStack with high expectations. And I think one of those expectations were to have a technology at hand that takes existing hardware in an existing data center, maybe, for example, offsite the public infrastructures, and make those infrastructures be a programmable data center. So basically, what you get when you want to, bootstrap VMs on AWS, you point your automation against their API, and you'll get your virtual machines. And the promise or the expectation around OpenStack was to get that into on-premise scenarios and your own private data center as well. So it is about getting virtual machines up and running, configuring the network, attaching and detaching persistent disks, and maybe an object store similar to Amazon S3, which was offered by OpenStack as OpenStack Swift. With a programmable data center at hand, the contemporary way to automate workloads was to have automation that allows you to have infrastructure as code. So instead of creating an application server manually uploading your code, you basically create an automation, for example, using technologies such as Puppet or Opscode Chef, to equip virtual machines with the software you need in an automated way, so that you have control over your automation as part of the code base of your application. So the entire DevOps movement, originating from 2009's Belgium DevOps camp in, I think it was held in Ghent, where the idea of bringing agile software development into operations followed up into paradigms such as infrastructure as a code. Now, OpenStack was appealing because all the major components were there. You had compute to cover virtual machines. You had software-defined networking to create virtual networks programmatically, as well as block and object storage. So why not take OpenStack and just put it in the data center, and you'll have your own little AWS. Once you have that, you can just take the API and perform your automation, live the DevOps stream and establish what was perceived as continuous delivery back then. So the question is, why isn't OpenStack widely spread nowadays? Well, there is a certain adoption, and no doubt about that. There are still people introducing OpenStack into their organizations. But I also have met many organizations who've been through what I refer to as the valley of darkness, where they tried to adapt and establishing such infrastructure in their own data centers, but they failed. The reasons for that, they may be vastly different. Some may have not spent enough resources to take care of the complexity of such infrastructure properly, or they were lacking of the required know-how and skill set in order to set up OpenStack. Or maybe it was because there was so much heterogeneity within OpenStack and the maturity and robustness of the software was insufficient, at least for non-OpenStack experts to download and bootstrap vanilla versions of it. Well, there have been commercial distributions, and I'm pretty sure after years, several of them can be quite, successful. But I'm more referring to the overall community and the expectations of those who were aiming at vanilla versions of OpenStack. So to some degree, it appears that the promise has failed. I mean, it was never easy to download OpenStack and turn, let's say, 50 servers into an OpenStack cluster, even if those servers were handcrafted in a sense that the hardware was selected correctly and all the building blocks were there. I would say that in the past year, a certain decline in OpenStack has been observed and the hype cycle has ended. While some of the arguments that I presented earlier may be the reason for that, for example, the lack of easy user experience, download, set it up, and there you go. Or whether it is that the technology has or is disrupted by another technology, another shift, another paradigm shift that occurs in the tech community. So another question, and one of the questions that is basically subject to this talk, is whether OpenStack is dissolving into Kubernetes. And as such, Kubernetes becomes a new OpenStack. And there are several angles that can be asked about that question. For example, whether you just take OpenStack and put an Kubernetes API in front of it, or whether Kubernetes at some point may fail similar to OpenStack. Well, personally, I don't think so, because Kubernetes has a different source of energy from the community. It is based on technology such as Borg that has been used in production for many years. And well, let's say Google is known for bringing up technologies that have a certain maturity level right away. And looking at the momentum and the size of the community and its popularity, when let's say at least ingredients are there that Kubernetes becomes more successful than OpenStack was. Although I have to admit that there has been a time when I was pretty much convinced that OpenStack is going to be successful, looking at the popularity momentum this project got. So surprising shifts can always happen, and nobody can foresee the future. But for what it's worth, I think there's a certain difference. So is OpenStack dissolving into Kubernetes? Well, you may know that this is happening if you order an OpenStack and what you get is a Kubernetes. Well, today you can see that companies such as Mirantis, for example, they already offer OpenStack along with a Kubernetes. Now, looking into the particular way on how Kubernetes is operated on OpenStack, we'll give you more details about whether there's a substitution happening or whether there's just onion skinning where another layer just is added on the top. So if what you get is OpenStack, but there's a tooling that spins up virtual machines and puts Kubernetes into those virtual machines, well, then you have onion skinning. So the container movement is happening for several years now, and as such, it changes the way we look at shipping software. So in 2012, maybe 2010, people were more attracted to virtual machines, and virtual machines were used to, well, let's say, set up application servers. With technologies such as Cloud Foundry becoming more popular and also inspiring, well, let's say, um, application platforms that are based on Docker or later Kubernetes, I think nobody really wants to bootstrap a virtual machine to turn it into an application server anymore. I think we are beyond that point in time. And in generally, it's safe to say that the container movement, with its lightweight containers, have gained a lot of momentum because of the inertia and overhead that comes with para-virtualized or full virtualized virtual machines. So the container movement introduces, among others, containers that were possible after the Linux kernels introduced cgroups and namespaces that allow the isolation of workloads on process level, isolating them at least with respect to CPU and memory, which happened in 2008. So there's less overhead compared to a virtual machine. And that also introduces different ways of packaging your software. Because with virtual machine, you'll be very, let's say, motivated to collocate several components in order to have a smaller overhead per component. Whereas with containers, adding a container doesn't really add a lot of overhead, and hence one process per container becomes a viable paradigm. So if you look into also the question on how do you develop on your local computer versus what is the production environment, it is much easier with containers to create something that works locally and that behaves at least similar if you put it into production. So also the way on how you create container images on versus how you create virtual machine images, it seems like the container images with the Docker format, for example, the Docker file, is something that's quite lightweight and easy to use. So the entire community around containers is also about refurbishing the tooling in order to describe workloads and make it more enjoyable and easy to write and maintain. All right, so after the containers and the container technologies, such as Docker and Rocket and whatever the name is, and the several layers of libraries in between, such as libcontainer and containerd, the emergence of container orchestrators were, well, let's say, the next logical step. And in comparison to orchestrating containers and virtual machines, there are a lot of similarities, but there are also differences. So in both cases, you have physical servers, and at some level, what you want is to carve your physical servers into smaller chunks and then have an API with a scheduler behind it where you can throw your workload at it, and which will then schedule your workload on any of those servers being a fit for the particular workload. So you also have to take care of networking so that virtual machines or containers can communicate along with each other, as well as you have to somehow find a solution to maintain state for applications that store information in the file system, as well as, well, maybe even databases where this is basically inevitable. So the container orchestrators, they come with APIs such as OpenStack did, but the way the APIs work are differently. They are different in a way that the API in Kubernetes is more declarative. It is similar, more similar to BOSH than it is to the OpenStack API. So in OpenStack, you basically tell OpenStack to create a virtual machine, which should be based on that particular image. And in a container, especially in Kubernetes, you describe, or you have the ability to describe the entire distributed system with the state you want it to be in once it is deployed. So that declarative approach gives you the ability to describe a workload, say, well, I want to have 5 different app instances of this app. I want to have 3 nodes for this database, and please deploy it all for me. And you do not have to orchestrate the particular sequence in which the pods have to be created, as this is done by the container orchestrator. You also get a lot of self-healing capabilities, as once you've described the desired state, you'll have this kind of event or this kind of watchdog, this event loop that continuously makes this comparison between the actual and the desired state, deriving actions from it in order to correct the system to be eventually consistent with the description of the desired state. Often, the container orchestrators, in particular Kubernetes, introduces load balancing and as an integral part of the system. Well, you could say that OpenStack has introduced things like that as several components, but I'd say it's safe to say that if you set up a Kubernetes cluster today, well, Kubernetes services are inherent to the cluster's abilities to handle workloads, and it's not a component that that you just skip, and it is something that you have to get from somewhere. It's part of Kubernetes, or at least it's the idea of Kubernetes that this place has to be filled. And well, even if both have load balancing, I think the way Kubernetes incorporates it into the ability to describe distributed systems from one single description is very different from what you had with OpenStack, where technologies such as heat had to be used in order to come closer to a declarative API. So you could say that container orchestrators are taking more responsibility in maintaining the actual lifecycle of the workload than it was with technologies such as OpenStack. So ongoing, well, at least a few years ago, technologies such as Cloud Foundry, where the idea was to have a platform for application developer productivity, including container orchestration, started to compete in that area or container orchestration with other technologies such as Kubernetes. And I think it's safe to say that Kubernetes has won the container orchestration wars. That doesn't mean that Kubernetes has defeated Cloud Foundry. There are other talks looking at that. I myself, I'm giving another talk, Irini versus Knative, where we look closer into the comparison of the two. So if you look into Kubernetes and you want to compare with the Cloud Foundry, the comparison regarding the orchestration wars would rather be a Diego versus a Kubernetes comparison than a Cloud Foundry versus Kubernetes comparison. So if you take your virtual infrastructure, you'll have your OpenStack or you have your VMware, and then you put Kubernetes on the top. And on top of that, you place your whatever Irini, KF, Knative, to then put your workloads on top of that. You'll have many different layers, and that becomes, to some degree, wasteful in itself, because those different layers do overlap, as we've seen earlier. They somehow address the splitting of hardware into smaller chunks. They somehow allow you to deal with networking, attach and reattach and detach storage block disks, as well as taking care of load balancing. So the question is whether Kubernetes nowadays slowly sinks into infrastructure and cannibalizing to some degree the domain of infrastructure technology such as OpenStack and VMware in general. So this is often referred to as Kubernetes as infrastructure. And there are various different ways on how you can use Kubernetes. And I've seen at least 3 different use cases. I've seen Kubernetes as more or less as a container orchestrator in the sense of creating a platform for applications. I have seen using the Kubernetes API for creating infrastructure. And I have seen Kubernetes using the API in order to orchestrate workloads on edge devices, small little computers running in industry and factory environments. So Kubernetes is not limited to the orchestration of pods and containers to run simple applications, but it actually breaks out of that scale or that jail and started to sink into the infrastructure itself, whether it is for regular cloud infrastructures or whether it is for factory and on and edge hardware. So if you look at Kubernetes and infrastructure, there are different ways on how Kubernetes can be consumed. So on public clouds, there's often an API where the creation and maintenance of the Kubernetes master and even the node groups for the worker nodes are handled and can be consumed via API. So it is very easy to spin up your Kubernetes cluster on Google Cloud Platform, for example, a few commands later, and you have your Kubernetes cluster up and running. Now, the drawback of that obviously is that once somebody else manages that for you, there's limited flexibility in it, and you are dependent on the features and the roadmap of your vendor of the public cloud. There's another possibility that is you'll have a tooling that allows you to create deployments on several infrastructures. What I refer to here as multi-infrastructure support are technologies that basically do support different infrastructures, but where the exploration of a new infrastructure is quite a lot of work. Whereas infrastructure agnostic automation is inherently free from the underlying infrastructure. For example, because it bases on a tooling that already does that. Multi-infrastructure support, a good example is COPS. So COPS you can use to deploy on various infrastructures, and you can do that with CFCR too. But with CFCR relying on BOSH, there's more homogeneity in the BOSH release, or at least in the user experience, than it is with COPS. If you now have to add a new infrastructure, the question is whether BOSH has already covered it. If BOSH has already covered it, you save a lot of time and you have usually a very predictable deployment of your workload using BOSH. So you can deploy Kubernetes with BOSH to several infrastructures, whereas with COPS, the differences of the individual offerings might become more visible. Just my opinion. Another aspect, referring back to the idea on whether the cloud stack with virtualization and containerization on top will basically collapse on its own weight, is also referred to VMware's latest project Pacific, where it seems like Kubernetes melts into the hypervisor, maybe not into the hypervisor, but at least into the infrastructure API. And Kubernetes becomes a first citizen. So you can talk to VMware and schedule your container workloads natively. And this means that there's a direct integration with ESXi and Kubernetes, so that you can use the Kubernetes API, but you'll get different flavors of containers. So some of them may even isolate it with virtual machines. So your pod is basically sitting on on-demand provisioned ESX nodes represented by dedicated virtual machines. There's another way on how the entire stack could even collapse further. And the most extreme example would be to put Kubernetes directly on bare metal. So let's say you just bake it into the operating system, and whenever you take your compute nodes as hardware up, you just take the whatever Kubernetes distribution that comes with your favorite operating system, and there you go. Without the underlying virtualization layer, you can even, get some extra performance out of it, but you also have to be aware that in itself, Kubernetes is not very well isolating your workloads from another. But this is a topic we're going to look at in greater detail. Kubernetes sinks and melts into deeper layers of the cloud stack is at least the way it appears. We have to wait and see whether Project Pacific will be the new standard and how well it is going to be accepted, and whether OpenStack companies like Marantis at some point will do a similar thing. So in general, whether or regardless on whether Kubernetes has sunken into the infrastructure stack or not, the question is whether the workloads will just pretend Kubernetes is the new infrastructure standard. Because then when you deploy databases against Kubernetes or into Kubernetes clusters, and you don't want to use any virtualization underneath, it maybe still be there, but it becomes meaningless for the description of your workloads. So the question on whether this is a thing or not, and I think there's a lot of popularity. Many people actually do that already. Companies like SUSE, companies like IBM, they've already pushed their products into that direction. Now, in general, you have to ask the question on who runs your Kubernetes, because this is also the details on how the Kubernetes is operated will determine on whether it will be a suitable infrastructure replacement or not. So a particular example for this would be the question on whether Kubernetes will kill BOSH eventually. And the biggest challenge to look into would be how would you operate a database in Kubernetes? Databases being inherently stateful applications where state is quite heavyweight. We're not talking about those applications that are slightly incompatible with the 12-factor manifest because they store, some assets into the file system, which they shouldn't. But we're talking about databases that inherently write into the data system, into the file system, and they expect a predictable performance from it, either from the file system itself or from a remotely attached block device, such as with persistent volumes is the case. So stateless versus legacy app does exactly that separation. You can basically run stateful workloads in Kubernetes, but to run or not to run a database on Kubernetes, the question is, what do you want to consider? And moving your storage application onto Kubernetes isn't always the right choice, as it has been stated in the Kubernetes blog linked below. So how important is predictable performance to you is another question asked in the Kubernetes documentation. What it means to answer this question can be visualized by looking into the general challenge with workload isolation. And for databases, this means I/O isolation. Containers already isolate CPU and memory quite well, but what about disk and network I/O? The problem of bad neighbors is known to anybody who ever lived in a multi-tenant apartment. And the isolation problem is in general that if you have two tenants sitting on the same host, in this case it's a physical host with two virtual machines, The question is, how does one disturb the other? So with two virtual machines, that is usually not a problem. With two containers on the same machine, this is a problem because container isolation is quite weak. Where, for example, you can set up your hypervisor to bootstrap fully virtualized machines where your network device and your storage devices are virtual too, giving you the opportunity to regulate and set policies around how to share the disk I/O of the underlying hardware along with your virtual machines. Where in containers this isn't possible. So if it happens that a neighbor container is very noisy because, for example, it hosts a database that is highly frequented, you can see that the adjacent containers will be very unhappy to a degree that it won't be possible to operate that container or those containers sitting on the same node. Now, with strong isolation, let me get to the right slide. With strong isolation, you solve bad neighbor issues and you'll get predictable performance. For virtual machine, that's the case, but for containers, it's not. You cannot predict the performance regarding the network I/O or the disk I/O without having a proper isolation. So the question or the answer I heard regarding that issue was that you can basically work around that. For example, you can use host affinity and anti-affinity in Kubernetes to ensure that a certain container is being placed or not being placed on a particular node. So yes, you can, but the question is, why would you? We've been at Any9s orchestrating and automating data services for more than 5 years now, and we have automated the lifecycle of 8 data services based on BOSH deployments. And we've been constantly looking for other automation technologies that may make our lives easier and maybe more efficient in describing the on-demand provisioning of thousands of databases from a single code base. We haven't found anything so far. Well, we did with Kubernetes find a technology that has similar properties than BOSH, for example, and where workloads could be described maybe even more easily, and that the spin of a container will be much faster, even fastening our development life cycles. There's a lot of advantages that are coming from Kubernetes as the underlying infrastructure. But as long as there's no isolation of disk I/O and network I/O, there's always be this problem, and you'll have to take care of it. How do you solve the bad neighborhood issue? So one of the ways, as I mentioned earlier, is influencing the Kubernetes scheduler to avoid bad neighborhood. Avoiding bad neighborhood in Kubernetes means to add labels to stateful sets, for example, to target pods to specific nodes or node groups. The question is, where do these nodes come from? So how can you ensure that if you want to create a new Postgres production crate, that there is a node waiting for that pod? So you have to on-demand provision that virtual machine, I guess. And if you have to on-demand provision that virtual machine, well, it can't be hardware. Because if you have sitting hardware in your data center, well, where's the advantage? Well, you could say you have the same problem with virtual machines. And yes, you do. But they have been solved already. So now you have to talk to 2 different layers. You have to orchestrate the workloads of your data services within Kubernetes, and then you have to ensure that they're virtual machines turned into Kubernetes nodes available to your scheduler when you need them. You can do that. It is additional work, though. In general, When I automate stateful workloads, I do not want to care about the placement of my workload. This is the purpose of the infrastructure layer. And this is what happened, and this is what was the case with BOSH and underlying virtual machines. So why accepting a drawback that important just because I want to use Kubernetes? So I'd say, provide me with well-isolated containers, or I will use a VM. I want to use Kubernetes, but maybe I need the VM. So one of the ways, as I mentioned earlier, is to have on-demand provisioning of Kubernetes nodes, where you provision a new Kubernetes node based on the demand to place a certain container that has constraints that cannot be fulfilled from the existing nodes. An example would be to have a dedicated node VM for a virtual machine representing a data service instance. So you create a Postgres, you need to schedule a pod that will demand its own dedicated VM. So then you provision that Kubernetes node so that the container scheduler can place your pod with your Postgres onto that virtual machine. So it is possible, and maybe it's going to be necessary, but hopefully you don't forget to automate the node deletion, because if you take away the pod, you also have to take away the virtual machine. So you have to keep the two in sync, which is additional work. And oh my God, we actually already solved this problem. Now we're going to back. We have to introduce more complexity to work around something that should be fixed on a different level. So the question is, why do I have to do that? Because Kubernetes doesn't provide a solid container isolation yet. So in my expectation, so many people are using Kubernetes to deploy stateful workloads. At some point, somebody will show up and solve this problem and provide Kubernetes containers with proper isolation. And maybe Project Pacific is the first, where VMware takes a step and says, well, if you want to have a pod that has performance isolation for I/O and network, well, we give you a VM. And we take care of the auto provisioning of that, so you don't have to put that into your data service automation. Well, fair enough. That could be a solution, and we'll see what happens. So, summing it up, the Kubernetes API becomes more popular beyond the scope of container orchestration. It cannibalizes to some degree infrastructure APIs as well. Thus, Kubernetes claims infrastructure territory, and maybe different Kubernetes flavor will appear, those dedicated for application workloads, those dedicated for more infrastructure workloads, and those dedicated for edge workloads in industry environments. If Kubernetes learns about well-isolated containers, it may become also home for heavyweight stateful workloads such as data services. Until then, we may want to use VMs instead. So is BOSH going to be the de facto standard for stateful automation? We will see. For now, when it comes to VMs, it surely is a solid choice. Feel free to ask questions, leave your comments, and reach out at any time. Thank you for your attention, and see you next time.